Unique reflections. So let's review a little bit from yesterday. We have here a reflection is a transformation that flips a figure over a given line. So a reflection is where the image flips. Now, don't forget, we had the x-axis reflection where the x-coordinate stayed the same. So we reflected over the x-axis, so the x stayed the same. The y-coordinate became the opposite. So when we did a y-axis reflection, okay, the y-axis reflection, the y-coordinate stayed the same and the x became the opposite. As you can see here, there are some cases where the original figure can be on both sides of your line of reflection. So the rule will stay the same. So you can see over here, here's my original example. Here's my line of reflection, which is the y-axis. If you notice, each coordinate, so my y is going to stay the same. So you can see down below here, the y stayed the same. The x was 1, now it became a -1. Similar over here. My y coordinate stayed 1. So my y coordinate stayed 1, but my x coordinate became the opposite, and so on. So here my y coordinate was -1. It still is -1, and my x coordinate, which was 1, became the opposite. Okay? So the same for the last ordered pair. Now, if the rule is a little tricky for you, I would then just take each individual point. So here's my first point, and I would count 1, 2 places away from the line of reflection. So it's going to be 1, 2 places away on the other side. So that would be my new point. So here, again, 1, 2 places. So I'd count 1, 2 places. That would be that new point. This one here, even though it's on the left side, now it's going to move to the right side. It's 1, 2 places away from the line of reflection. So 1, 2 places from the line of reflection. And there was this last one, which would end up, okay? So when you drew your new picture, it would look like the following. And so that new picture looks like the one below. It's just a little crazy looking because it's on top of the other one. But that's all you would need to do. All right, so let's continue. Now, there are not just reflections over the x and the y axis. There are sometimes reflections over specific lines given in the picture. For example, here we have this line, y equals -1. Notice, here's my line. So, I would maybe use a highlighter if I had paper. Okay, so here's my line of reflection. Let's say if I put a point, I'll pick right here. Okay, so I want to reflect that point over that line of reflection. Well, I'm going to count how far is my point away from that line. So let me call this A. It is 1 space away from that line of reflection, so you're going to count 1 space on the other side. So 1 space over here, that would get me my new point. These do not have rules that you need to remember, like the x and y axis reflection. So that would get you your new point. So similar on the other side, now we have this line, this vertical line, x equals 2. So let's say if I made a point, let me pick, say for example, that point. I'll call this B. So I'm going to count how far is that point away from my line of reflection, and it is 1, 2 places away. So on the opposite side, I'm going to count 1, 2 places away. So that would give me my new location for point B prime. That's all you would need to do. And if there were more points in the picture, you would count each individual point and move that just like I did with those 2 examples. All right, last example. So now we have a whole picture. Before I was just making random points. So here I have my line of reflection, and of course if you don't have a highlighter because it's not on paper, just use your pencil and put it up to the screen so you can see where your line of reflection is. All right, well on this one, notice here's this point. If you count how far is that point away from your line of reflection? So on this one, it says 3 units to the line of reflection. That's because this here is 1, the scale on the X and Y axis. So that would count 1, 2, 3 places to get to my line of reflection. So I'm going to count 3, 1, 2, 3 on the opposite side, and that would give me my new point. And I would do the same on the others. So here's this original point, count how far. So every 2 spaces on this particular graph counts as 1. So that's 2 places to the line of reflection. So I'm going to count 1, 2 places, and that gets me my new point. And the last one, 1, 2, 3 places. So count 1, 2, 3 places. Okay, then you would draw your new picture, and you would have your new picture for the reflection over that particular line. So when it gives you a random line on the graph, just count how far is each point away from that line of reflection, and count that same amount on the opposite side of the line of reflection to get your new image point. Good luck.